here that some exterior angle is equal to sum of two opposite interior angles. So this way, actually, you have to write the theorem in bracket. It is required in exam that what theorem you are using here. So how much is t, Zainab? 65 minus 28?
37. That is 37.
37. Just a minute. Okay, if I take it to be 37, let's say, are you sure 65 minus 28 is 37? 15 minus 8.
Yes.
Yeah, okay, seems fine. So if t is 37, how much should be angle x then? Now, see, it is given that PQ is parallel to SR. So if the two lines are parallel and there's a transversal, so this angle should be equal to this angle, right?
Yes.
Alternate interior angles. So ultimately, your angle X is equal to angle T, which is alternate interior angle. So I should
Yes.
get my angle X is equal to
37.
37 degree. Is it right? Can you just check the answer in your book?
Yes.
Okay. Right. So it is 37. Now come to this triangle PQY. Now in triangle PQS triangle. So I think Z plus Y plus X, the sum should be 180 degree. Angle sum
Yes.
property. The sum of
Yes.
all the angles is 180. Now angle Z is 90 degree and angle Y I want to find. Angle X is 37, that is 180 degree. So it should be like Y plus 7 and then 9 plus 3 is 12 is equal to 180 degree. And Y is equal to how much? 180 minus of 127?
53.
53 degree. So I have got like Y 53 and X is 37. So these are the two.
Hello?
Yes, Lakshita, can you hear me?
Yeah.
Okay. Okay, Lakshita, actually just one last question is remaining and then I'm going to start a new chapter. So you just listen till then, okay?
Okay.
So have you noted, Zanab, Adil?
Yes, ma'am.
Okay. Let's do the last question, sixth one. So the figure looks like this. Okay. P, T, Q, R, and then S. Now, what is given in the question is the side QR of a triangle PQR is produced. Fine. If the bisector of angle PQR meet at T, then prove that angle QTR is half of angle QPR. Okay. So basically, like this was the complete angle, right? And
Yes.
this QT is the bisector of it. So that means this angle is equal to this angle. All right, Adil?
Yes.
Okay. And similarly, this was a complete angle and this RT is the bisector. So like this much part is equal to this much part. Fine. Let me give some names to angles to make it look simpler. This I'm calling 1 and this I'm calling 2. Then let me call this the angle 3, 4 and this one 5. I mean this one. And let me call them XY. Fine. So it is given in the problem that angle 1 is equal to angle 2 and angle 4 is equal to angle 5. This much is given, right? And you have to find or to prove that angle QTR, which is QTR, that means, okay, right. So angle QTR is half of angle QPR. Or I can write like this, QTR means that X is equal to half of Y. Ultimately, this you have to show, right? Okay, let's do proof. Now we start with this triangle. In triangle PQR, right? I can use angle sum property, right? If I write like this, like angle Y plus, put angles here. Okay, angle Y plus, then this complete angle Q. So angle 1 plus angle 2, right? And then plus angle 3. It should be 180 degree. Any problem?
No.
Angle sum property. I'm just taking it as my equation number 1, right? Now come back to another triangle. So in triangle QTR, right? Again, use angle sum property. So that means your angle 2 plus angle X plus then
4,
angle,
5,
no, not 4, 5, 3 and
3,
4,
4.
right? 3 and 4 are inside. So sum of all these angles should be 180 degree. Again, angle sum property. So I'm marking it as my equation number 2. Okay. Now basically 1 and 2 I have to solve. Now before that something else is given. Now what is given here? Now it is given that angle 1 is equal to angle 2 and angle 4 is equal to angle 5, right?
5.
This much
Yes.
is given to me. And also if I use the exterior angle property, like for triangle QTR, so can I write angle 2 plus angle X is equal to angle 5? Fine, Adil?
Yes.
Exterior angle property, right? So, I mean, this information I'm calling 3 and this information I'm calling 4. So these are the informations I have. So I'm going to use 3 and 4 in equation number 1 and 2 now, right?
Okay.
Okay. Now, first of all, 1 and 2 both are equal to 180. So I can equate them. So equating equation 1 and 2. Both are 180. So that means their left hand side is also equal. So I'm using a blue pen here. So angle Y plus angle 1 plus angle 2 plus angle 3. This is equal to angle 2 plus angle X plus angle 3 plus angle 4. Is that okay?
Yes.
Okay. Now, first of all, I can see angle to both side. So I can cancel it. And
Yes.
also I can see angle 3 both side, that I can cancel. So I'm left with only angle Y plus angle 1 is equal to angle X plus angle 4, right? Okay. Okay. Now angle 4, now in place of this angle 4, let me change this angle 4 here. Okay. See, ultimately, I want to get a relationship between, you see here, x and y. Fine.
Yes.
So on one side, I have my x, on one side, I have my y, right? Now, one side I have angle 1, one side I have angle 4.
Four.
So I can change my angle 1 also, I can change my angle 4 also. Ultimately, 1 I have to change so that I can get the same thing on both the side and that can cancel out. All right.
Yes.
So this is what I'm trying to do. If I just rewrite this thing, this equation, right? I'm using these results here. So in place of angle 2, I'm writing angle 1 from here. Angle 1 is equal to angle 2. Fine, Adil?
Yes.
Okay. And in place of 5, I'm again writing angle 4, right? So basically, the third results I've used in equation number 4. All right. You can write
Okay.
rewriting equation 4 by using third. So I have used third and I have rewritten my fourth. Now I'm going to use this result here, right? So in place of this angle 4, I'm going to write this angle 1 plus angle x. Is that okay?
Yes.
So angle y plus angle 1 is equal to angle x plus. Now angle 4, I can write angle 1 plus angle x. No issues. So you can see angle 1, both side cancels out. So I'm left with angle y is twice of angle x and half of angle y is equal to angle x. This is what I was supposed to prove. So you can give it names that half of angle QPR is equal to angle QTR. It is looking a bit messed up, I think, but should I do it again?
No, ma'am.
You can, like, when you write in the copy, you can start from here. I mean, the third and fourth results, at least you can write first of all, and then you get this equation, and then you start with these two triangles. So it will not be that messy, and just equate the two equations, right? So this lines and angles chapter is complete. Please like give it a good revision, practice the questions. I'm going to start a new chapter today, that is chapter number 1. Okay. Number system. Yes, Lakshita, Adil. See, you must have done this chapter in your schools, but again, I'm going to start from the very basics of number system.
Yes,
First,
ma'am.
yeah, so let's have a review of numbers or introduction. Now you must have heard about different names, that is integer, whole number, rational number, right? Natural number, prime number, even number, composite number. So many types of numbers. Now how they are related to each other. First we start with the natural numbers. So first thing, we start with natural number. They are basically counting numbers. So when we count something, the numbers we use are natural numbers. So for example, you have so many things in front of you, like so many books. So how will you count? You will start from one, right? One book, two book, three book. So these numbers, that is 1, 2, 3, 4, 5, and so on, they are called natural numbers. Understood?
Yes, sir.
Yeah. So because they are counting numbers, they don't start with zero, right? When you count something, you always start with one. Then next set of number which comes are called whole numbers. Whole numbers, they start from zero. So if we include zero also, then it becomes a set of whole numbers. Fine, Adil?
Yes.
Okay. Now you can see they are all positive. We don't have any negative number here. So if we also include negative numbers, then what will happen? So basically I have 0 here, then 1, 2, 3, 4, so on. And on this side, if I take like, let's see, I'm writing on the number line, right? So -1, -2, -3, like, so this complete set will be called as integers. Is that okay? So integers basically include negative numbers also and positive numbers also. So if we combine them together and plus 0, it will be called integers. Now, only this much, if I want to summarize, how will I summarize here? See, the first set is called natural number, right? And
Yes, sir.
if I add 0 to it, it will become whole number. So basically, if this is a box, so this box is actually contained inside this whole number. Understood? So whole number also include natural numbers. So 0 and these are all natural numbers, right? So natural numbers form part of whole numbers also. So if I have a box of whole number, so I'll also find natural numbers inside it. Understood?
Yes.
Okay. Now if I look at integers, so this much part, like this much part is what? These are my whole numbers, right? So that means if I have a box of integers, let's say this is my box of integers. So my box of integer is also going to contain whole numbers. Fine, Lakshita?
Yes, sir.
Yes. And whole number contains natural number. This I know. Because these are what? These are natural numbers starting from 1. So natural numbers are included in whole number. Whole numbers are included in integers. So this is how my box is looking right now. Understood?
Yes, sir.
Okay. Now next type of number which I have are called rational numbers. Okay. Now so far I have dealt with positive numbers, then I have included 0, then I have included negative numbers. What about these kind of number, let's say 5 by 3 or -7 by 5, like fraction kind of numbers? So these are called rational numbers. Understood? So these numbers are of the form P by Q. Understood?
Yes, sir.
Yeah. For example, 5 by 3, -7 by 5. So these are rational numbers. There's a condition that Q is not equal to 0. The denominator should not be 0, because when something is divided by 0, for example, I divide 5 by 0. What is 5 by 0? It is not defined, right? When we divide a number by 0, it is not defined. So there's a condition that in rational number, the denominator cannot be 0. So any number of the form P by Q is rational number. Okay.
Yes, sir.
Okay. Now tell me, if I write 3, is it a rational number, Adil?
Yes.
Okay. What about you, Zainab? Is it a rational number? Please unmute your mic. Yes, Lakshita, what do you think? If I write 3, is it a rational number?
Yes.
Why yes? Yes, it is a rational number because 3, I can write 3 as 3 by 1. Any problem?
No.
Yes.
No.
So it has become of the form P by Q, isn't it? Where my Q is 1 and P is 3. So any integer can also be written as a rational number. So if I make a box of rational number now, right? This is my box of rational number. So ultimately my box of rational number also contains integers. Understood? And integer contains whole number and whole number contains natural number. So this is how my box is looking right now. Understood?
Yes.
Okay, so rational numbers, integers, whole numbers, and natural numbers. So these 4 we have known so far. Now next set of number, have you written all of you, Lakshita? Please make this
Yes, ma'am.
diagram also. I mean, this will make the picture clear in your mind. Very roughly just make it. Done?
Yes.
Okay. Now, then comes another kind of number which are called irrational number, right? Irrational. Now, what are irrational? Obviously, the opposite of rational. The number which are not rational are irrational. Fine. Now, but how we define it? It is these kind of number where I have under root, let's say under root 2, under root 3, under root 5. So these are called irrational numbers, right?
Yes, ma'am.
Okay. So whenever you have an under root, this will become irrational number. So we will come to irrational, then we will see how we deal with it. So for the time being, this much introduction is fine. Yeah, and one more thing. Now, if I take all these numbers together, right? If I add all the numbers like natural numbers plus whole number plus integers plus rational plus irrational, if I take them all combined, they form a set of real numbers. Fine. They are called real numbers. So if I make my final box of real numbers, what does it contain? Real numbers, basically, first of all, it will contain 2 types of number. One is called rational and one is called irrational, right? Now, this rational is actually a one box, right? It contains what? It contains integers inside it, as we have seen. Then this integer box will contain whole numbers inside it, and this will contain natural numbers inside it. And this complete is your real number box. Understood? So that's the complete picture. Yes, Zainab, are you here in the class?
Yes, ma'am.
Okay. So please make this final diagram. In class 10th, first chapter is also, the name of the chapter is real number. So there also you will be requiring it. So you should have an understanding of what are real numbers. Right. So basically in class 9th, we separately deal with rational and then irrational. But in class 10th, we call it combined real numbers. Okay. Right. I think you have drawn it.
Yes, ma'am.
Right.
Yeah.
Okay. So let's do some questions, and with the help of questions, we will understand. First of all, there's a number line, which obviously you all must be knowing. How does it look like? Let me just draw one number line here. So you have a 0, then you have positive numbers at equal space, like equal distance from each other, then -1, -2, and -3, -4, -5, and so on. So this is how your number line looks like. Now, if I give you first question that represent 5 by 3 and -5 by 3 on number line. So far, you know how to plot natural number, whole number, and integers on number line. This is what this I have plotted integer on number lines, right? Now I have my number of these kind 5 by 3. So where will I place 5 by 3 on this number line? Where will I place minus 5 by 3 on the number line? So this kind of number we will be dealing now. Okay, now how to do it? So 5 by 3 and minus 5 by 3. So basically 5 by 3 means what? I'm dividing 5 into 3 parts, right? What is the meaning of 5 by 3? That I'm dividing 5 into 3 parts, right? So
Yes.
yeah, so I'll draw a number line. I'll mark my 0, right? So I mark 5 here and then I take minus 5 here. Now this distance 5. So ultimately I have to divide like this complete distance 5 into 3 equal parts. Okay. So I'm dividing this into 3 equal parts. So let us try to plot this positive one first of all. So I'm dividing this into 3 equal parts, right? So what is the first part? First part is basically 5 by 3. Next part is what? 2 into 5 by 3. And this third part, which is 5, this is nothing but 3 into 5 by 3. Understood? So ultimately 3 cancel out and you get 5. Okay.
Yes.
Yeah, Lakshita. See, you have divided 5 into 3 parts. So you have 3 parts now. The first part is 5 by 3, right?
Yes,
Then
ma'am.
you have another 5 by 3, then you have another 5 by 3. So this much distance will be 1 into 5 by 3. All right. And from 0 to here, this total distance is 2 into 5 by 3. And from 0 to here, this total distance is 3 into 5 by 3. So this is the position of 5 by 3. Understood?
Yes, ma'am.
Yeah. So this is where you are going to plot it. And similarly, on the negative side, again, you are dividing this. Minus 5 is because of it is on the left, but ultimately the distance is 5. So you're dividing your distance into 3 equal parts. So the first part is again minus 5 by 3. The second part will be minus of, sorry, minus of 2 into or 2 into minus 5 by 3. This way you can write. And this third part is nothing. It's actually 3 into minus 5 by 3. So ultimately 3 cancels out and you get minus 5. So these 2 points you are interested in, 5 by 3 and this one, minus 5 by 3. So I hope you have understood, both of you, 3 of you, sorry.
Yes.
Okay. Is there any confusion, Lakshita, Zainab? You can ask me.
No, ma'am.
Fine. Another kind of number we will learn now. So this was about number line. So I hope you can plot now. Okay, now the second type of questions will be like this, that find a rational number between let's say minus 3 and 7, right? So you have to find a rational number between minus 3 and 7. So you can directly tell also, if you just close your eyes, just imagine a number line. So obviously between minus 3 and 7, you can tell me any number. It can be positive 5, it can be 2, 0, 1, right? But how to do it like mathematically? So ultimately you will add the two number minus 3 plus 7 and then divide by 2. So what will you get? This is 4 by 2 and this is 2. So this number 2 will fall between minus 3 and 7. Understood?
Yes.
Okay. Then if I ask you to find a rational number between minus 2 by 3 and 1 by 4. Okay, Lakshita? This is
Yes,
like
ma'am.
another question. So minus 2 by 3 and 1 by 4. In this case, it was easy to tell You can tell me different numbers. You can tell me 0, 3, 2, 4, 5, 6. They all lie. But these are fractions having different denominators. So how will you do it? Again, you will do the same way. You are going to add them. So 2 by 3 plus 1 by 4, right? And this whole divided by 2. Understood? So the number which you will get from here, it will fall between them. Okay. Just let me just show you one thing. For example, this is your number line. This is 0, this is 1, this is 2, right? I want to find a number between 1 and 2. Understood? So if I just do this thing, that 1 plus 2 divided by 2, what will I get? 3 divided by 2. This will be 1.5. So you can see 1.5 is greater than 1, smaller than 2. So it will lie between 1 and 2. Understood? So that the same thing I'm doing here. So this will become, now you take LCM. So 3 and 4 is 12, right? And then 3 into 4 is 12. So minus 2 into 4 plus then 4 into 3. So 1 into 3. And this whole thing divided by 2. All right. So this will be minus of 8 plus of 3 divided by 2. Again divided by 2. So this becomes minus of 4 and divided by 2. So this becomes minus of 4 by 2 and into, now this 2 will become 1 by 2, right? This is how you do it. If you change the division sign into multiplication, it will become 1 by 2. So that will be minus 4 by 4. Have I done it right or something mistake I've done? Minus 3, it should be 5, isn't it? And it was 12, right?
Yes.
Yeah. So ultimately I'll get minus 5 by 24. So minus 5 by 24 is the number which will fall between minus 2 by 3 and 1 by 4. Lakshita, is this okay? Now all three of you, yeah, all three of you will tell me a number quickly between minus 3 by 4 and 2 by 3. Now please tell me. Yeah, who has done it? Adil, have you done it?
No.
Yes, Zainab, what about you?
No, ma'am.
Lakshita,
No.
is it that tough? Come on. Okay. So these are the two numbers, right? How will you solve it? So you will write the rational number between minus 3 by 4 and 2 by 3 is. Okay. Okay. What is that number? It is or equal to, you can write. So it is minus 3 by 4 plus 2 by 3 divided by 2. Understood? This is the number. All right.
Okay.
So see, these are simple addition of fractions. That's it. You can do it. How will you solve it? Is equal to, take LCM, right? Okay, who is having problem in taking and solving LCM? Tell me very honestly at this step. See, this is the first chapter. At least we will start learning calculations also. Whoever is having problem, now pay attention here, right? Now, how do we add or subtract fraction? Whenever we are adding or subtracting fraction, the only way is to take LCM, right? You cannot do it directly. So LCM of 4 and 3. What is the LCM of 4 and 3? So 2 into 2 and 3 will come out. Then 2 into 1 and 3. Then 3 into 1, 1. So unless you get all 1, 1, you will keep doing prime factorization. So the LCM is 2 into 2, 4. 4 into 3 is 12. So my LCM is 12, correct? Okay. Now we know that 4 into 3 is 12, right? So 3 times it is going. So that 3 will be multiplied with the numerator. So minus 3 into 3, all right? Plus. Now we know that 4 times this 12 will go with the denominator. 3 into 4 is 12, right? 4 times it will go. Here it was going 3 times. So 4 will be multiplied with the numerator. So 2 into 4. Understood? So this becomes minus 3 into 3, minus of 9, plus 2 into 4 is 8 divided by 12. And that becomes minus of 1 by 12. All right. This is how you are going to add it. Understood?
Yes.
Now since I have already done it, so I'm going to write directly. So minus 1 by 12 divided by 2. Is that okay? So whenever you change the division sign into multiplication, the number actually got inverse. So 2 will become 1 by 2. Okay. So this will be minus 1 by 24. So minus 1 by 24 is the number which will fall between minus 3 by 4 and 2 by 3. Yes, Lakshita, any question? Please feel free to ask if you have a problem at any step. Zainab,
Yes, ma'am.
any problem here?
No, ma'am.
Okay. Lakshita, any problem here?
Ma'am, the
Hmm.
4 into 3 and the 3 into 4 part time.
Okay, one more question I'm going to take. For example, I want just learn again, Lakshita. Please note it down also and learn. First, see on the screen. If I want to add fraction, for example, I have fraction 2 by 3 plus, let's say 4 by 7, right?
Yes, ma'am.
Okay. These both are fractions I want to add. So first thing is we take LCM of 3 and 7. So do you know how to take LCM?
Yes, ma'am.
Okay. So 3 and 7 are actually both prime numbers. So 3 into 1 and 7 into 1, 1. So ultimately 3 into 7, 21. 21 is my LCM. So we basically, now we have 3 in the denominator, right? Here.
Yes, ma'am.
So you recall the table of 3. So you know 3 into 7 is 21, right?
Yeah.
So this number 7, I mean, you don't write it here, but you know that 3 into 7 is 21. So that 7 will be multiplied with the numerator. Understood?
Yes, ma'am.
Okay. Now come to the table of 7 because you have a 7 here. So you know that 7 into 3 is 21. Understood?
Yes, ma'am.
So this 3 will actually multiply with the numerator. So 3 into 4. This is how we write it. Okay.
Yes, ma'am.
So basically you have to see the table and you see how many times it is occurring in the table. With that number, you multiply the numerator. So just simple now multiply. So 7 into 2 is 14 plus 3 into 4 is 12 divided by 21. And then you add it. So 26 by 21. This is the answer. Understood?
Yes, ma'am.
So please write it and write these also so that you remember. I mean, write these also.
Ma'am, I do.
Okay, fine. Now, next type of questions are these that find 3 rational numbers. Between -2 and 5, right? So far we were finding only one rational number. Now I want to find 3 rational numbers. Okay. So the first number will be first number, simply I'll do the same thing. So -2 plus 5 and divided by 2. Understood?
Yes.
Yes, ma'am.
Okay, this will give me one number. So I'll get -2 plus 5 is 3 divided by 2. So this is 3 by 2, right? Or if you want to convert into decimal, that also you can do. But anyway, leave it here. So 3 by 2 is one number. So actually, if I have a number line, for example, I have -2 here and 5 here. So somewhere between will lie 3 by 2. 3 by 2 is actually 1.5. So somewhere here it will lie. Let's say this is my 3 by 2, right? Okay. Now, if I again add these two number and then divide it by 2, so I'll get a number between these two, right? And also, if I just add these two and then divide by 2, so I'll get a number between these two. So ultimately, all these numbers, I mean, this number plus this number plus this number, they all are coming between -2 and 5, isn't it?
Yes, ma'am.
Is this clear, Zainab?
Yes, ma'am.
Okay. So the first number is this -3 by 2, which I have found between -2 and 5. So this is my first number. Now I'm going to add these two, -2 and 3 by 2, so that I can get a number between them, right? So second number will be,
So, ma'am,
so I'll do -2 plus 3 by 2 and then divided by 2. Understood? Okay. So just solve it now. So -2 plus 3 by 2. So -2 can be written as -2 by 1 and plus 3 by 2, right? Divided by 2. Or you can just change it here itself. So it will become 1 by 2. Now you take LCM. So 1 and 2 LCM will be 2. So 1 into 2 is 2 and 2 into -2 plus, so 1 into 3, right? And then into 1 by 2. So -2 plus
Ma'am,
3.
can you,
Okay. Right, Lakshita. Now see here, -2 plus 3 by 2. This I'm adding, right?
Yeah.
So this -2, can I written -2 by 1? No problem.
Yes, ma'am.
Any number I can divide by 1. So you take LCM of 1 and 2. You will get 2 as the LCM.
Yes, ma'am.
Okay. Now you know that 1 into 2 is 2, right?
Yeah.
So this 2 will be multiplied with the numerator. So 2 into -2, right?
Yeah.
Plus. Now 2 into 1 is 2. So this 1 will be multiplied with the numerator. Any problem?
No, ma'am.
So this I have done. Okay. So sorry, this will be -4 now. So this will be -4 plus 3 divided by 2. Understood? So this I have done here. So this will become minus of 1 by 2 into 1 by 2. So I'll get minus of 1 by 4. Fine, Adil?
Yes.
So on adding them,
Mm.
yeah, so I have got a number minus of 1 by 4. So ultimately it is lying between them. Now next time I'm going to add these two and I'll get a number between them. All right. So the third number will be so this time I'm adding 3 by 2 and 5. And then divided by 2, right? Okay, I'm doing the calculation here. So this 3 by 2 plus 5 by 1 I can write, and then I'm changing it multiplication, it will become 1 by 2. Now this bracket, first of all, let's solve it. So take LCM 2. So one time it will go, so it will 3 plus 2 time it will go, 2 into 5 is 10, and then into 1 by 2. So this is 13 by 2 into 1 by 2, and that becomes 13 by 4. So the another number I have got is 13 by 4. So you can see all these three numbers, this number, this number, this number, they all are falling between -2 and 5. So these are the three numbers I've got, right? The first number, and then the second number, and the third number. Any problem here? I hope you have written, all of you.
Yes.
Okay. Now please understand one thing. Okay, what I did it, I had -2 and then I had 5, right? So I have added both of them and I have got a number here somewhere, let's say here in between -2 and 5. So then I added like this number and this number, right? And then I have got another number here. So the next number, it's not necessary that I add these two. In the next step, I can add these two also and I'll get something here. Or I can add these two also, I'll get something here, right? In the next step, let's say I can again add these two, right? Or I can add these two, or I can add these two. Like any adjacent numbers you can add. Ultimately, all these numbers are going to fall between -2 and 5. I hope you have understood, Zainab.
Yes, ma'am.
Adil, have you understood? See, please be honest. If there is any, if you want me to show it, I can show, no problem.
I have.
Okay, Zainab, have you understood?
Yes, ma'am.
Okay, Lakshita,
Yes, ma'am.
okay. Then there is one more kind of question, which is like this, that you have two numbers, let's say -3 by 11, and then another number is 8 by 11, right? Now I'm saying that find 10 numbers between them. So there's another way of doing it. one method can be this, that you keep on adding and dividing by 2, adding and dividing by 2, and you find 10 numbers. That can be one method. The second method can be like this, that you write it like this. We know that. Can we just start from -3 on the number line? So the next number will be how much? -2, then -1, then I'll have 0, then 1, 2, 3, 4, 5, 6, 7, and 8, right? So up to 8 I have written. I've started from -3, I've till 8 I have written my number line, right? Okay. Now if I divide all the numbers by 11, there's no problem. So I can write therefore, so -3 by 11, or instead of comma, can I write like this, that 8 is greater than 7, right?
Yes.
I can also write them like this. So basically it is saying that all these numbers are falling between 8 and -3. So if I divide all these numbers, so I'll get -2 by 11, -1 by 11, then 0 by 11, it will remain 0, right? 1 by 11, 2 by 11, then it will be 3 by 11, then 4 by 11, 5 by 11, then 6 by 11, and then 7 by 11, and then you have 8 by 11, right? So we have seen that on the number line, it will look like this, that -2 and by 11 is greater than 3 by 11, like that. So I can pick any 10 numbers between this and this, no problem.
Yes.
So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So
10.
I have 10 numbers which are actually falling between -3 and -8, and sorry, +8. So you will write the 10 numbers are -2 by 11, then 1 by 11, then you have 0, 1 by 11, 2 by 11, 3 by 11, 4 by 11, 5 by 11, and 7 by 11, right? So these are the 10 numbers which are falling between -3 by 11 and 8 by 11. Fine, Lakshita?
Yes, ma'am.
Okay. So have you written?
Yes, ma'am.
Yes.
Okay. Let me just clean some slides. Another is that I have number -3 by 13 and 9 by 13, right? I'm saying that insert 100 numbers between them. Now, how will you tell me 100 numbers between -3 by 13 and 9 by 13? So we do it like this. So minus, like solution, we can say. So -3 by 13, if I just multiply and divide the numerator by 10, no problem. So -3 by 13, I'm multiplying with 10 and I'm dividing by 10, no problem. Ultimately 10 by 10 is 1, I'll get the same number. So this becomes minus of 30 divided by 130, okay? Okay, and the 9 by 13 also I'll do the same thing. So both numerator and denominator I'm multiplying by 10. So that becomes 90 divided by 130. Understood?
Yes.
Yes,
Okay.
ma'am.
Okay. Now, see, we know that if you see on the number line, how will it look like? You have minus of 30. Then if I take interval of 10, 10, so I'll have -20. Then I'll have minus of 10. Then I'll have 0. Then I have 10, 20, like this. Fine. So basically, and I divide all the numbers by 130. So it will look like this, right? I'm dividing all the number by 130. So I'll start from here, like minus of 30 is actually smaller than minus of 29, right? It is smaller than minus of 28, is smaller than minus of 27, and it will keep on going. Then you don't have to write all the numbers. Ultimately, you will get a 0 here, right? And then 0 will be smaller than 1, will be smaller than 2, it will be smaller than, and then you will keep on writing, and then last you will get minus of 88 is less than 89 is less than 90, right? So you have started from minus 30 and then you have written up to 90. So how many numbers will be there between minus 30 and 90? 100, right? Okay, you see the number line here. Now please try to understand this thing. See, I have a number line, right? I'm taking intervals of 10, 10. So minus of 30, minus of 20, minus of 10, then I have 0, then 10, then 20, 30, 40, 50, 60, 70, 80, and 90. So how many numbers do I have? See, from minus 10 to minus 20, how many numbers? 10 numbers, right? So each interval has 10 numbers between it. So 10 plus 10, 20, 30, 40, 50, 60, 70, 80, 90, 20. Sorry, 90, 20, what I did, I sorry. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. In fact, I'm getting more than 100, so I can pick any 100 from here. Up to 70, I'm getting 100. So I think I don't have to write up to 90 here. I can end it here, like minus of 68, then 69, then 70. So I'll get 100 numbers. Is this clear to all of you?
Yes.
Yes, Lakshita. Okay.
Yes.
See, is this number line clear to all of you?
Yes.
Simple number line I have drawn. So basically between the two numbers, I have an interval of 10, right? Right? So this is how I'm writing it. So 10 numbers here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So at 70 itself, I'm getting 100. So I can write up to 70 only. I don't have to go up to 90. Now I divide every number by 130. Because I have 130 in the denominator, so I'm dividing all the numbers by 130. So it implies that minus of 30 divided by 130 will be smaller than minus of 29 divided by 130 will be smaller than, sorry, 130, and so on, right? It will go on. So it will be smaller than 0, it will be smaller than 1 by 130, and so on, right? It will go on. So minus of 68 by 130, 69 by 130 will be smaller than 70 by 130. So I can pick 100 numbers from here. So therefore, the 100 numbers are, now what are the 100 numbers? So I can pick all the numbers between. So I don't have to pick them, I have to pick between them. So I'll start from here. So minus of 29 by 130, then minus of 28 by 130, and so on. I'll get 0, then I'll get 1 by 130, then I'll get 2 by 130, and so on, so on, so on, so on. And I'll get 69 by 130. And before this, I have 68 by 130. That's it. So don't take this one because, no, you take this one. Otherwise, the numbers will be 99, right? Is that okay? See why? See, try to understand this thing. Let's say I'm picking number from 30 and 40 till 40. How many numbers will be there if you start? So 30, 31, 32. So ultimately you are going to get 11 numbers, right? Correct?
Yes, ma'am.
Yeah. So you don't start from 30. If you start from 31, so you will get 10 numbers up to 40. So because I'm starting from minus 29, so I'll take up to 70. If I would have started from like minus 30, then I would have ended at 69 by 130. Is this point clear to all of you?
Yes.
Okay. This first chapter is a bit, it's easy, but anyway. Okay, so I hope you have understood this thing. Let's come to NCERT exercise now. Just give me a minute. I'm just inserting the questions. Number system. Yeah. Yeah, so can you see the screen now?
Yes, ma'am.
Okay. Now, is 0 a rational number? Okay, what do you think? Is it a rational number? Okay, 0. Is 0 an integer?
Ma'am,
Yes, Zainab.
your screen is not visible.
Not visible. Mm. Is it visible now?
No.
Ma'am, I can see it.
Exercise 1.1.
Yeah.
Okay, I'll do one thing. Mm. Yeah, Zainab, now is it visible, my OneNote?
No, ma'am.
Yeah, Adil, can you see my OneNote? I mean, my screen, can you see?
No.
Ma'am, I don't think you said.
Oh, sorry, I didn't share. Yeah, now is it visible? Zainab?
Yeah.
It's not.
But to other students, it is visible. Zainab, please check.
Can I even join?
Adil, is my screen visible this time?
Yes.
Okay. Yeah, Zainab, please try to rejoin. Some problem with your...
Yes, ma'am.
Okay, so we were discussing that is 0 a rational number? Okay, before rational number, tell me, Lakshita, 0, like, is it an integer?
Yeah.
Okay, so obviously it's a rational number then, because the box of rational number contains integer. So if something is integer, it is obviously a rational number also, right?
Yes, ma'am.
So yes, I mean, it is a rational number. Now, can you write it in the form P by Q? Yes, obviously we can write. I mean, 0, I can divide with any number. I can divide by, let's say, 2. It will remain 0, no problem.
Yes,
I can
ma'am.
write 0 by 1. I can write 0 by 100. Ultimately, the answer will be 0. So 0 can be written in the form of P by Q, right?
Yes, ma'am.
Okay, Zainab, this time now is it visible?
Yes, ma'am.
Fine. Second question, find 6 rational number between 3 and 4. Right? So who will tell me how to do it? Just orally tell me what should I do?
3 plus 4 by 2.
Yes, okay, good. So first number, yeah, okay. So I'm doing question number 2 now. So what will be my first number? So first number is simple add. So 3 plus 4 and divided by 2, right? So I'll
Yes.
get 7.
7 by 2.
7 by 2 is my one number. So if you just like in your mind, for example, you have 3 on the number line and then you have 4 here. So somewhere, let's say you got 7 by 2. I'm not sure where it will lie, but let's say it is lying here. This is actually your rough part, right? So let's say it is lying here. Now, if I add 3 and 7 by 2, so I'll get a number which will lie here in between, right?
Yes.
Okay. So the second number will be, fine, Lakshita. So this time I'll add 3 and the 7 by 2, which I have
7
found.
by 2.
So again, you have to take LCM. So you will write it 3 by 1 plus 7 by 2. Then take LCM. LCM will be 2.
2.
And then 1 into 2 and 2 into 3 is 6. And then 7. So it will be 13 by 2, right? So somewhere here you have a new number that is 13 by 2. Fine. Now third number. Third number I want to find. Now I can add any, like I can add 3 plus 13 by 2 again, right?
Yes.
So 3 plus 13. One mistake I have done, I have not divided this by 2, right? So into 1 by 2. So ultimately you will get 13 by 4, right? If you will do your calculation. Clear? You have to divide by 2 also. So the third number is 3 plus 13 by 2. And this
13
whole,
by 4.
yeah, this time 13 by 4, good, and divided by 2, right? This will give you third number. So what is the number? Adil, tell me quickly. Adil will tell, only Adil. Adil, are you in the class? Yes, he is.
I don't know.
Why you don't know? What? No, this is not an acceptable answer. Solve it, Adil. 3 plus 13 by 4. What is the issue? You do it separately. I mean, let me solve it for you here. Now start from here, Adil. 3 plus 13 by 4. This is what you want to solve, right? Yes?
Yes.
Okay. Now take LCM. So basically you have 1 here, right? So LCM will be 4. Is this clear?
Yes.
Okay. Now 1 into 4 is 4. So 4 into 3. Understood? Plus. Now 4 into 1 is 4. So 1 into 13. Is this clear?
Yes.
Okay. So 4 into 3 is 12. Plus 1 into 13 is 13 divided by 4. So you got,
24.
no, 12 plus 12 is
25
24. Yeah,
plus 4
25 by 4.
by 4.
Yeah. So this will become 25 by 4 and divided by 2. Clear, Adil?
Yes.
Yes. So you now change the division into multiplication. So 25 by 4 into this 2 will become 1 by 2. So you have got a number 25 divided by 8. Clear? Lakshita, clear?
I didn't understand why you changed the to multiplication.
Ultimately, okay, you have something like 25 by 4 divided by 2, right? What
Yeah.
does it mean? You can write it like this: 25 by 4 divided by 2. Is that okay now?
Okay.
Okay. So basically, okay, let me just move here. Now learn this thing, all of you. If you have numbers like this, 2 by 3 divided by, let's say, 1 by 5, right? Fraction divided by fraction. How do you solve it? So ultimately, you multiply like the outer numbers together and they go in the numerator. So it will be 2 into 5. Understood? And the inner numbers, they are multiplied together. It will come in the denominator. So 3 into 1. Fine?
10 by 3.
Yeah. So 10 by 3. So is this method clear?
Yes.
Okay. So now Adil, you have 24, 25 divided by 4 and then divided by 2. Is this okay?
Okay.
Yes.
So if you have 2, so 2 can be written as 2 by 1, no problem.
Yes.
Okay. So ultimately it will be 1 into 25, right Adil? And then 4 into 2. Is this okay?
Yes.
So outer numbers multiplied by together with inner numbers. So this is the answer, 25 by 8. Or if you just look at it carefully, so this can it be shifted like this, 25 by 4 into 1 by 2? Can I write it like this?
Yes.
So basically you have seen when something is written like this, 24 divided by 2, so ultimately it becomes like this. That 2 actually comes in the denominator. Okay, if you have a confusion here, don't do it this way. Do it this way, simple. When you have this 25 divided by 4 and divided by 2, Adil, right? Simply do it this way, 25 by 4 and divided by 2. So I think you can do it. I think the issue is not yet solved. Okay, just stop thinking about the chapter, just simple calculations. Now learn here, all of you, please pay attention. For example, let me take some numbers. I'm taking 2 by 3 divided by 5. Fine, Adil?
Yeah.
Okay. So one method can be this, that I directly change the division sign into multiplication and the divisor will become reciprocal. So it will be 2 by 3 into 1 by 5. So this division has changed into multiplication. Understood? Lakshita? Yes, Lakshita. Okay, Adil. So these are the two methods of division. One method is this, that you change the division sign into multiplication directly. Okay. If you don't want to do it, what else you can do? You can do this way. So this you can write 2 by 3 and divided by 5. This way you can write, right?
By 1.
Yeah. I mean, this is the first step. Okay. This is how you will write. Then because you only have 5, so you can write it 5 by 1. So this is now looking fraction upon fraction. Understood?
Yes.
Okay. So basically this will be 2 into 1
Into
divided by 3
3
into
into
5.
5.
Isn't it, Adil?
Okay.
Yes, the inner numbers together, the outer numbers together. So don't you think they're looking same?
Yes.
Yes, Adil?
Yes.
So ultimately you are going to get that the same thing. So either way you can do it, no problem. You can actually divide it or you can simply change the sign into multiplication. You will get the same thing. So I hope it is clear to all of you now.